Lesson 11. Modeling with differential equations. Differential equations can be used to model real-life situations. Let's do one example. The rate of increase of a population P of bacteria at time t hours is given by dP over dt is equal to 3p. The initial population of the bacteria is 8. Part A. Find a model for P in the form P is equal to A multiplied by e to the kt, stating A and k. Part B. Find the nearest 100 the size of P when t is equal to 2 hours. And then Part C. State one limitation of the model for large values of t. For Part A, we have dP over dt is equal to 3p. By separating the variables, we can create the integral of 1 over p with respect to p is equal to the integral of 3 with respect to t. This gives us the natural log of p is equal to 3t plus c. Raising both sides to the e power, we get p is equal to e to the 3t plus c, which can be rewritten as e to the 3t multiplied by e to the c. And as e is a constant and c is another constant, we can just write this as a multiplied by e to the 3t. Now we need to find a. We know the initial population is 8 bacteria. This is when t is 0. So we can say 8 is equal to a multiplied by e to the 3 times 0, which is just 0, and e to the 0 is 1. So we get a is equal to 8. And so therefore, p is equal to 8e to the 3t. For part B, we have p is equal to 8 multiplied by e to the 3t. When t is equal to 2, we get p is equal to 8e to the 3 times 2, which is 8e to the 6. This is about 3,227.43 and so on, which gives us around 3,200 bacteria to the nearest 100. For part C, you could say something like, the population wouldn't increase in size the same way forever due to limitations such as available food or space. You should make sure your answer is relevant by always referring to the context of the question. And that's about it.